We've looked at the scenario where there is no triangle possible, and we just looked at the scenario where there's two triangles possible, and now we're looking at the scenario of the side-side angle where there is just one possible triangle. Algebraically, I'm just going to show you how to set this one up. We can assume that there's a second triangle and then see if that second triangle is going to work. So we'll first draw our triangle. Triangle ABC. We'll fill in our values. A is 43 degrees. We have little a is 81. Little c is 62. So we've got side, side, and the angle opposite. The only thing I can do here, I've been given the full ratio for A. I'm missing angle C and I have side C. I know nothing about B. I'll set up the ratios using A and C. Get 81 over the sine of 43 degrees equals 62 over the sine of C. Solving for sine of C, we get 62 sine of 43 degrees over 81. Solving for C, C equals the inverse sine of 62 sine 43 over 81. We're going to assume that there's two possible triangles, and then we'll throw one of the angles away if it doesn't work. We know when we start, if we do inverse sine, and we'll do the 62 times the sine of 43 divided by 81, close the parentheses, hit enter. I've got an angle of, if I round to the nearest whole number, 31 degrees. Again, the calculator is, if there is an angle, it's always going to give us the acute for this type of problem. We'll call this C1. And we want to, let's find C2 and then we'll figure out if we can use it or not. What we just found here was the acute angle, which is the first quadrant angle. We need to find the second quadrant angle, which we said would be 180 minus the 31 degrees. So the 180 minus the 31 degrees gives us 149 degrees. We were given 43. So we know there's at least one triangle, and that triangle is the scenario where angle C is 31 degrees. That would be your acute. To see if there is that obtuse scenario, we would need to take our new angle, that 149, and add that to the given angle of 43. That will give us 192, and that's too big. Too big for a second triangle. So in this case, we know algebraically that there's only going to be one triangle, and at this point you could solve this triangle. I'm going to leave that up to you. You would solve the rest of this triangle, and knowing that there's only one possible triangle. We could find angle B by subtracting these two from 180, and then using the law of sines to find that missing side. So the important key, or the important feature of this problem, is to determine algebraically if you have two triangles or not. We start off by finding our acute angle. We know that's going to give us one triangle. We assume there's a second triangle, or at least try to find it by finding C2 by subtracting our given angle, or the acute angle, from 180 to find that second quadrant angle. If when you add that to the given angle of the problem and you are over 180, then you do not have enough room for a second triangle. So what I'd like you to do at this point is pause the video, try the three practice problems, and again, if you want to try them one at a time, try the first problem, check your answer, try the second problem, check your answer, and then try the third. It's up to you. Okay, so we're going to draw a triangle, assuming that there is an answer. We'll label our triangle, and we can see we've got the side-side angle scenario, and we're going to solve this using the law of sines. So the first thing I can do is to find angle B. I know nothing about C, so I'll use the law of sines. I'll set up my ratios. Sine of B equals 30 sine 150 over 10. B equals the inverse sine of 30 sine 150 divided by 10, and we'll evaluate that on our calculator. Inverse sine 30 sine 150 divided by 10. I get a domain error. So my assumption is at this point that there is no triangle, but you want to double check and just make sure you didn't type something in incorrectly in your calculator. And so at this point, what I'd like to do is to just evaluate this expression in here to see if we get a value that is greater than or 1 or less than -1. So 30 sine 150 divided by 10, and we get 1.5. So since this is equal to 1.5, it's too big. So there is no triangle possible for this given problem. Looking at the next problem, so we draw our triangle. Got angle A is 20, side B is 40, side A is 30. We know nothing about C, so we set up our ratios using A and B. 40 over the sine of B equals 30 over the sine of 20. Solving for sine B. Sine B equals 40 sine 20 over 30, which means B is equal to the inverse sine of 40 sine 20 over 30. So inverse sine 40 sine 20 divided by 30 we get, and we round to the nearest whole number, we get our acute angle is 27 degrees, rounding to the nearest whole number. We'll call that B1, and we'll find B2, which would be 180 minus the 27 degrees. Remembering again that the acute angle would be our first quadrant angle of 27 degrees, but we also want to find the possibility of an obtuse, and to find that we would take the 180 and we would subtract the reference angle of 27. We get approximately 153 degrees. So to see if there is a second triangle, I will draw a second one. And this second triangle and we draw the second triangle. We have A is 20, angle A. This is still the same, the 30 and the 40. And B is now 153 degrees. Now, if there is a second triangle, when I add 153 to the 20, as long as I'm less than 180, I have a second triangle. And we do have a second triangle. And so what we'll do is we'll go back and solve the first, then we'll come back down here and solve the second. So for the first triangle, we've got angle A and angle B already. We need angle C, which we would find by taking 180 and subtracting A and B. So C equals 133. Again, not drawn to scale, and now I use the law of sines to solve for C, so I'll set up that ratio. 30 over the sine of 20 equals C over the sine of 133. C would equal 30 times the sine of 133 divided by the sine of 20. And if we round that to the nearest tenth, we're going to get 64.2. We have all three sides, and we have all three angles. So now we'll go down and we'll solve the second triangle, the one that has the obtuse angle. And again, we start by, we'll find C, which equals 7 degrees. And then the last thing we need to do is find side C by using the law of sines. 30 over the sine of 20 equals side C over the sine of 7. C is going to equal 30 times the sine of 7 degrees divided by the sine of 20. 30 sine of 7 divided by sine of 20. And we get, rounding to the nearest tenth, 10.7. So 10.7. And as before, you can check your answers by comparing all of the ratios and see that you get the same value. All right, let's try the last one. We'll draw the triangle. And we'll first solve the triangle for angle C. Solving for sine B. And B will be the inverse sine. Second, sine. 4 sine 162 divided by 6.1. Close the parentheses, hit enter. So we get, if we want to round our angle to the nearest whole number, we're going to get 12 degrees. To find the obtuse angle, we would take the 180 and subtract the 12 degrees, which would give us 168, which when added to the angle that we were already given, the 162, would be too big. The 168 plus the angle that was given, the 162, is definitely greater than 180. So we only have one triangle, and so we'll solve this triangle here that we have. So we'll solve for the missing pieces. We'll find C. So C equals 6 degrees. And then the last thing to find is side C using the law of sines. 6.1 over the sine of 162 equals C over the sine of 6. So C is going to equal 6.1 times the sine of 6 divided by the sine of 162, which is equal to, if we round to the nearest tenth, 2.1. And again, you can check these ratios by setting up the law of sines for each pair, angle, and side.